Hello everybody, this is Mrs. Snook with section 7.1, which is our first section in chapter 7, and this chapter is all about exponents. And in today's lesson, we're going to simplify exponents that have zero or negative exponents. So first of all, just what is an exponent? I'm going to give you an example. Here's 2 to the 5. 2 is the base. And 5, that little 5 up there, that's called the exponent. And what this particular notation means is I'm going to take the number 2, and I'm going to multiply it by 2, and I'm going to keep going till I have a total of 5 2's. Because 2 to the 5 means 1, 2, 3, 4, 5 2's. And if I was to work that all out, this will come up to 32. Now, a 0 exponent would look like this, 2 to the 0. A negative exponent will look like this, 2 to the negative 3. And as we go through today's lesson, you will learn how to evaluate those types of exponents. So let's get started. First of all, let's take a look at a chart of exponents here. We have 2 to the 4th, which is going to be 2 times 2 times 2 times 2. We're going to have 4 2's in there. And that's going to work out to 16. And then if I only had 3 2's in there, that would be 2 times 2 times 2, which is 8. And then 2 2's is 4. 1 2 is just 2. So notice the pattern. Each time I reduce my exponent by 1, I'm dividing by the base. So if I do 16 divided by 2, I get 8, which is the same thing as 2 to the 3rd. Divide by 2 again, I get 4, which is the same thing as 2 to the 2nd. Divide by 2 again, I get 2 to the 1st. So what if I divide by 2 again to get 2 to the 0? Well, 2 over 2 equals 1. So I get a 1 in there. 2 to the 0 equals 1. Now if I keep going, let's reduce my exponent by 1 more. Now I'm at 2 to the negative 1. I'm still going to divide. So 1 becomes 1 over 2. And then if I go again, 2 to the negative 2, divide again, I get 1 over 4. So hopefully what you noticed was that when you raise a number to the 0 power, you get 1. Now this is true for every number all the time. So 4 to the 0 equals 1. Negative 3 to the 0. Yes, this works with negative numbers. It still equals 1. 5.14 to the 0 equals 1. You can make up any number you want. 6,328 to the 0 equals 1. All the time, every time. Now, negative exponents. So on our chart, as the exponent went negative, I hope what you saw is 2 to the negative 1 equals 1/2. So notice the 2 went down into the bottom. 2 to the negative 2, I said, was 1/4, but isn't that also the same as 1 over 2 to the 2? So what do you think 2 to the negative 3 would equal? 1 over 2 to the 3. So when you have a negative exponent, it's just going to move. If it's in the top, you move it down to the bottom. If it's in the bottom, you move it to the top. So 7 to the negative 3 is 1 over 7 cubed. And then negative 5 to the negative 2, that negative 5 goes down to the bottom. And then instead of negative 2, you make that a positive 2. So let's do some examples of this. First one is 9 to the negative 2. So that's in the upstairs. So think of this as your house, and you have an upstairs and a downstairs. Because our 9 to the negative 2 is in the numerator, it's in the upstairs. Well, I'm just going to move that to the downstairs. So 9 to the 2. And change its sign. It's no longer a negative 2 anymore. It's now a positive 2. But the sign of the 9 stays the same. So now that I've moved it downstairs, I need to put something in the upstairs. I can't just leave it blank. So you put a 1. And then you'll notice it's simplified when you don't have any negative exponents anymore and you don't have any numbers to an exponent. So I'm going to simplify this 9 squared to 81. Next one, 8 to the 0. Well, that's a 0 exponent. Anything raised to the 0 equals 1. Last one, 6 to the negative 1. Move it downstairs. 6 goes downstairs. The 1 becomes a positive 1. Upstairs is empty, so put in a 1. Now we don't have to write the number to the 1. So this 6 to the 1, you don't have to write that 1. So you can just say 1/6. Now we're going to simplify some more expressions. It's getting a little bit more complicated now because we've got some variables. So take a look at example 4. We have 5a cubed b to the negative 2. So 5a cubed, that's all fine, but I've got a negative exponent here. Move that b downstairs and then change its exponent from negative 2 to positive 2. 1 over x to the negative 5. Well, x to the negative 5 is in the downstairs. I have to move it. So I'm going to move it upstairs. Change that exponent from negative to positive. And then I don't need an over 1, so this just becomes x to the 5th. Now we've got n to the negative 5 over m to the 2. Move the n to the negative 5 downstairs. It was upstairs, it goes downstairs. My m to the 2 does not have to move, so it's going to stay downstairs. And then put a 1 on top. If there's nothing left in your upstairs, you got to put a 1 in there. All right, I want you to try these yourselves. So you've got 3 to try, and pause the video while you figure this out, and then come back and play the video, and then you can compare your answers with mine. So pause your video now. Okay, we're back. Did you move n to the negative 2? Move that to the upstairs, so that becomes n squared. Move m to the negative 3 downstairs, so that becomes m to the 3. So our total new expression is going to be n squared over m to the 3. On b, y to the 0, anything to the 0 is going to equal 1. And you don't have to multiply by 1, so just write 4x to the 5th. And then on c, p to the negative 4, move that upstairs. So you get 7t cubed p to the 4. All right, so when we evaluate expressions, what we can do is plug those numbers in. And then there's always a question. Do I simplify first or do I substitute first? Well, let's see. So we're going to start with 3s cubed t to the negative 2. Now that t to the negative 2, that's upstairs. It's going to go downstairs. Okay, so I did that. Now I'm going to substitute in. S is 2. T is negative 3. And make sure you put that negative inside the parentheses because that says negative 3 times negative 3. So then I get 3 times 2. A negative 3 times a negative 2 is a positive 9. We're going to do some canceling. And I get 2, that's 2 cubed. So I get 8. I'm going to get 8 over 3. The other option is to substitute first. So let's try that. I have 3s cubed times t, which is negative 3, to the negative 2. Now that has a negative exponent. I have to move it downstairs. So 3 times 2 cubed over negative 3 squared. I get 3 times 8 over positive 9. Cancel, cancel. And I get 8 over 3. Either way works. Isn't that neat? It doesn't matter. You can simplify first, or you can substitute first, and as long as you're following those rules of exponents, moving the negative exponents and putting in a 1 for a 0 exponent, you're going to get the same answer. How about this one? What is the value of n to the negative 1 over w squared? So let's go ahead and substitute in. I'm going to have negative 2 to the negative 1 over w is 5 squared. That's going to give me 5 squared stays downstairs. But that negative 2, it's to the negative 1, so move it downstairs. That becomes a positive 1. 1 goes on top. So 1 is negative 2. 5 squared is 25. So I get 1 over negative 50. All right, so now we're going to use an exponential expression in a real-life situation. We have a population of marine bacteria doubles every hour under controlled laboratory conditions. The number of bacteria is modeled by the expression 1,000 times 2 to the h, where h is the number of hours after a scientist measures the population size. Evaluate the expression for h equals 0 and for h equals negative 3. And then what does each value of the expression represent in the situation? So here's our expression, 1,000 times 2 to the h, and h equals hours. So the first one is when h equals 0. Well, what does that mean? That means the experiment has just started. So this is your start time. Now put in a 0 for the h. So 1,000 times 2 to the 0. Well, that 2 to the 0 goes to 1, because anything to the 0 equals 1. So I get 1,000. So this means that my population is starting with 1,000 bacteria. Now we're going to put in h equals negative 3. Well, h is negative, so this means it's happening before the start time. Let's plug in 1,000 times 2 to the negative 3. Well, that's in the upstairs, so move it to the downstairs. I get 1,000 over 2 to the 3, which equals 1,000 over 8. Grab your calculator, do 1,000 over 8, and I get 125. So this means that 3 hours before the scientists started the experiment, there was 125 bacteria. All right. Thank you for watching, everybody, and have a great day.